So let's just take a look at how PDAs work in comparison to NFAs. First off, let me point out that just like there are a bunch of different NFAs for a particular language, you can also have a bunch of different DFAs, or DFAs for that language for sure, but also PDAs for that language. And you may think that one of these NFAs, which happens to be for the language A star B plus BC, is better than the others, is more intuitive, makes more sense to you, whatever. But I hope that if you look at this, at all four of these NFAs, and maybe you want to pause the video, you can see that all of them actually accept A to the A star B plus BC. Now, of those four NFAs, the one that people will often complain about the most is this one. And what you want to do is you just want to take a look with this NFA and say, people will say, well, what if my A star B, what if the A star part is just lambda? So then I just have the string B, does this accept that? Because they look at this and they say, oh, well, it looks like it forces you to have an A by having to go from Q0 to Q2. But in fact, if you look, if you just have the letter B, this NFA accepts it fine because it just takes this transition instead. So here's one PDA for A star B plus BC. Again, it's not necessarily the best PDA, but it's very similar to the NFA that I showed you, so I've picked this one. Now, if you look at the two of them side by side, what you'll see is that if we just look at the PDA for a minute, all of the instructions on the PDA have a letter, right? A letter that's in the string, and then comma, and then all of them have X over no op. Okay, so this means if there's an X at the top of the stack, which remember is what goes in the stack no matter what, then no op, don't worry about the stack. So this example is actually a super don't worry about the stack example where every single one says don't do anything with the stack and just make sure that there's an X at the top of the stack before you do anything. And of course, there's always going to be an X at the top of the stack because we didn't do anything and we start out with the X there. So let's just take a look and do an example on this NFA of a string and then on the PDA on the string, and then I think you'll feel better about what's going on. So for starters, see if you can ignore the PDA, and let's just do the example on this NFA for the string A, B. So if we have the string A, B, then we start at Q0, and we see the letter A, so we process it and we go to Q2, right? So let's get rid of that one, and now we know we're at Q2, right? So maybe we say, this is kind of our notation I think I sometimes use. You say you started at Q0, we saw an A, so now we're at Q2. And then we see another A in our string, right? So we're just going to loop and stay at Q2. So we're going to process that next A and stay at Q2. Sorry, my 2 doesn't look really all that good there. We see another A, and so we're going to loop again and stay at Q2. So we stay at Q2. And then finally we see, let's cross that A off because we've processed it. And then we see the letter B, and the only thing we can do from here, even though it's an NFA, it's a pretty straightforward NFA, is we can jump to Q3. So we use up that B, and we jump to Q3, and we're now done, right? We're at Q3, our string is all used up, and Q3 is a double circle, so we say, hurrah, it's in our language. Now let's do that same example on this PDA down here. Now we have one issue here, which is that little kind of, you know, up, down, up, down, up, down approach that I did with the NFA. That works well with an NFA, it doesn't work so well with a PDA. So what we're going to do is we're going to start this new notation for PDAs where we're going to say, I'm going to show you what's on the state, what's left over of the string, what I haven't crossed out yet, right? So what state I'm on, what's left over of the string after I make that step, and what is on the stack, just so we can kind of keep track of everything. Because I could, I could try and write it here on the stack or whatever, but it's going to get messy, and this way you can kind of follow an example afterwards. So let me slide this over here a little bit so you can see. So we're looking at the string AAAB. So in our first step, we started state 0, right? The string that we have to process is AAAB. Let's see if I can scooch this over just a little bit. There we go. String I have to process is AAAB, and on the stack is an X. How do I know there's an X on the stack? Because there's always an X on the stack when we start, right? The empty stack is symbolized by having an X. Okay, so we see this first letter A, right? And we look at our NFA and we say, where can I go? And there are two possible options here. One option is if I see the letter B, well, that's not going to work, so forget that one. The other one is if I see the letter A, well, that's good. And I have an X at the top of the stack, well, that's good too, because my stack, if I were to draw my stack, I drew it over in the corner, but now you can't see it, right? But if I were to draw my stack here, right, my stack just has an X on it, and I haven't added anything to it, right? But I also know that because I can look at the notation here, there's an X on my stack. So if I have the letter A and there's an X on my stack, then I'm going to jump on this transition and do a no-op, right? So that means I'm going to end up at state 2 having used up this A. So at this point, I can say, well, now I'm at state 2. The string that I have left to process, this is kind of like after I cross out that A, right? I have AAB, and what's on my stack? Well, I still have an X on my stack because I did a no-op. And now the next letter that I see is an A, and there's an X on my stack. So I look, and this one says, well, if you have a B, well, that doesn't help me, but I have an A. Oh, look, if I have an A and an X on my stack, then take this loop and do a no-op. So I'm going to stay at 2, having processed that A. So now I'm still at state 2, but since I used up this A, my string is just AB now, and I still have an X on my stack. Okay? And let's see, we're at state 2, and the next thing that we see is an A. So again, we have to take this loop because we see an A, and there's an X on the top of the stack, so we're good. We can take this loop. And so now I stay at state 2, but my string is, I used up the A, so I just have a B. So now I'm at state B, but since I did a no-op, still an X on my stack. I know the stack seems pretty useless because I've just got these no-ops still, but you'll see what happens in a minute that makes it more interesting. Okay? And then now I see a B, right? And so I can't take that loop anymore because that loop needs an A. So I see a B. Well, this one looks promising. I got to check what's on the stack. An X. Yeah, so I have an X on the stack. So it says B, X, no op. So I use up that B. I don't change the stack, and I jump to state 3. So now I am at state 3, and there is, let's see, I used up that B, so there's nothing left in my string, just lambda, and I still have an X on my stack. And now what you need to do, if you have lambda in here, in other words, you've used up your string, you need to check and say, is 3 a final state? Because if 3 is a final state, then yes, you win. So yep, we win, and this string is indeed in our language. Okay, so that was a very easy example on a kind of a very easy PDA that didn't use the stack. And of course, if you have a regular language, which is what we have, right? AAAB is a regular expression, and so that represents a regular language. If you have a regular language, then you can always do it with an NFA, so that means you can do it without a stack. Let's take a look at a slightly more complicated PDA that also recognizes this language. Okay, so here's another PDA that represents A star B plus BC. It looks a lot different. It's not necessarily better or worse. It's just another approach to building a PDA that accepts this language. Notice that I've got a bunch of, I have 4 different transitions here, right? You'd be used to if I'd had ABC or AAA, A, A on a regular PDA, you know that just means that it actually is a shortcut for 4 arrows here, right? But it's just, we're going to use this one transition arrow to represent all of those transitions. And similarly, we're going to use this single arrow to represent these 3 transitions. And since I couldn't fit them in, I squished that extra one at the bottom. And let me just walk you through a few different examples. And I think when you see the examples, you'll understand what's going on. Okay, so let me pull this up here a little bit. So the first example I want to do is the example that we did previously. I want to do A, B. So let's see, 1, 2, 3. I don't remember if the other one was 3 A's or 4 A's. Let's just do 3 A's and a B. And we're going to use that same notation. So I'm starting at state 0, of course, and I start with an X on the stack because we always start with an X on the stack. Now, to start out with here, I have, let's see, I have an A that I'm processing in my string, and I have an X at the top of my stack. So here's one transition that I could use for it. Of course, this could be non-deterministic. I might have a bunch of choices, but let's just see. So that this, A is my next letter and X on the stack, that works. I can't use this one because it says you have to have an A on the stack. And I can't use either of these because they say I have to have a B as the next letter. If we look down here, this says I have to have a C as the next letter, so that's no good. These two, however, are free jumps, lambda jumps, right? And before, we could just take them whenever we wanted. Now, we can take this one if we have a B on the stack. Well, I don't have a B at the top of the stack. And this free jump I can only take if I have a Q at the top of the stack. Well, I don't. So I guess the only thing I can use right now is this transition right here. I see an A in my string and I have an X at the top of my stack, which is true over here. So we're going to take this loop. And as we take that loop, what's going to happen is our next 3 tuple will say 0. And of course, this A we're done with, right? So now we have A, B, comma. And we look at the transition we took, and it says after we're done taking the transition, push an A. So we need to put an A onto our stack. And so, if we're using the stack over here, then we just kind of add an A up there. That doesn't look much like an A, does it? Over here, what I'm going to do is I'm going to just write the stack from left to right, everything that's on the stack. So we have an A at the top and then an X. All right, so let's see. So now we have an A that we have to process, and we have an A at the top of the stack. So let's see. We don't have a C, so we can't use that one. We don't have, we could use a free jump if the stack matches, but here we have a B and here we have a Q, and those don't match, so we have to go look at these guys. Of course, if we can't find anything that works, then we lose. It's not in the language. We have an A and a capital A, right? And I think I said this before, but I like to use the capital letters for pushing and popping off the stack just because it kind of mirrors the terminal or the non-terminals in our grammars when we use grammars, and I kind of like that idea. So these guys have to have B's in the string, so no good. This one has to have X on the stack, so no good. You can see I'm avoiding this one, and of course I'm avoiding this one because this one actually works. So we have an A in our string, that's the next to be processed, and an A at the top of the stack. So we're going to do this one. We're going to take this loop, process this A, and then at the end, we're going to push another A onto the stack. So now if I get a pencil, we're still at stage 0. Our string is now just AB that we have yet to process, right? Just like with our NFAs, we use up letters in the string. And an NFA, we would just be crossing it out. But of course, since I have to keep track of the stack, this approach makes a little more sense. So, and remember, we took this transition, so it says we have to push an A when we're done. So now we have AX on our stack, right? Okay, we have to process an A again, and we have an A at the top of our stack, so we look at everything and we realize we have to do this guy again. So let's do that. So we're going to we're looping still, we're at state 0. Now our string is reduced down to a B and just a B, and of course this says we have to push an A after we take that loop. So we'll push another A. So now we're going to have 3 A's on the stack, followed by an X at the very bottom. Okay. And now it gets a little bit more interesting. We have a B as the next letter up, and we have an A on the stack. None of these guys still work, right? Because that one doesn't match the B. We'd have to have the letter match that B for the first thing to work. These guys are free jumps, so if our letter on the stack matches, we're okay, but of course we have an A on the stack and these don't, so we go back up here, and look, here's one. if you have a B as your letter and an A on the stack, then you can push B and again stay at state 0. So okay, let's do that. So we are at state 0. Now we're down to lambda. We've used up all the letters in our string, and we're going to push a capital B on the stack. So it looks like this. And now, since we have a string that's lambda, we can say, oh, well, is state 0 an accept state? And the answer is no, 0 is not an accept state. So that's not going to work for us. So we have to see, can we keep going to somewhere that might accept? And so we have to see, we have a lambda. We don't have any letters to process, but we have a B on the stack. And if we look, all those have letters you have to process. This you have to process a C. But look, we have 2 free jumps. And one of those free jumps says if you have a B at the top of the stack, you can take this jump and do a no-op. Now, free jumps don't have to have a no-op, but this one does. So what we're going to do is we are going to take that free jump and the no-op. So we end up at state 1. So we end up at state 1. We didn't process anything because we took a freebie jump. And it was a no-op, so that tells us this is still on our stack, right? So over here, our stack actually now has 1, 2, 3 A's and a B above that X, right? So that's the way the stack looks. And at this point, we look at the fact that, again, we have a lambda in our string, so we can check to see whether the state we're currently at is an accept state. And sure enough, 1 has double circles, so it's a final state for our PDA. So we say, yep, the string AAAB is in our language, right? So AAAB is in an element of our language. Okay? So there's one good example. Now, let me clean this up and we'll do another example. Okay, now let's try processing the string BB, which is not in our language, so we sure as heck hope it isn't actually accepted. So of course we're going to start at state 0. Our string is BB, and we have an X on our stack because we always start with X on our empty stack. And now let's see, we have a B and an X on our stack, so none of the free jumps let us jump with an X. This has to have a Q and it needs a C anyway. Here's our only B ones. Oh look, BX push Q. Okay, and I can't remember if I said this or not now, but I made it push Q here just because I want you to know that the letters don't necessarily have to match up. So what we're going to do is we are going to say, okay, I'm taking that loop and I'm so stay at 0, and I now have a B left in my string because I processed that first B, but now I have, instead of just an X, because, here we go, because this thing said I have to push Q after I take the transition, now I have to push Q onto my stack. So now my stack has a Q and then an X, okay? And now we take a look and we have another B, and let's look at all the possible transitions we could take with a B. Well, this one says a B, but you have to have an X, and we don't. We have a Q at the top of the stack. This one says a B, but you have to have an A at the top of the stack, and again, we have a Q at the top of the stack, so that's no good. This one is requiring a C, so that's no good. This one is a lambda and requires a B at the top of the stack, so that doesn't work. Oh, look, here's a free jump that says you can take this free jump whenever you want as long as you have a Q at the top of the stack. Okay, so let's take this free jump because I don't see anything else we could do, right? Sometimes there's more than one option on a PDA, but not in this case. So we will take the jump to 1. So we're going to be at state 1. We took a lambda jump, so we didn't use up that B. It was just a free jump. And at the end of doing that jump, it says that we're supposed to do a no-op. So we just leave the stack alone. So our stack still has QX on it. Now, we are at state 1. And if you look at this, there's nowhere else for us to go, right? So if we get here and the string is empty, we don't care what's on the stack when we get to an accept state, right? But if we're here and the string is empty, then we'd say, yes, it's in our language. But we still have stuff to process and we don't have any way to process it. And there's nowhere else we could have gone. So in this case, we're going to say, nope, not in our language. So we're going to say, you know, the string BB is not in the language. What do we got? Well, we're still using regular expressions, so I can just write it like that. A star B plus BC. Okay? Let's do another example. Why don't we just look at the single B for a minute? So if we just have the string B, then we started state 0. We have X on our stack. And I'm going to go do this a little bit more quickly, but if you look at this, none of these guys work. These two don't work. This one doesn't work. Here's the only one that works, right? We have a B letter to process and an X on our stack. So we're going to take this loop and then push a Q. So we have we're taking the loop, so we're still at state 0. We're using up that B, so now our string is just lambda. And we're pushing a Q, so now our stack is QX. And now we look and we say, oh, look, I have the lambda, but I'm not in an accept state, so that doesn't get me anything. But we can still take this free jump, right? This is a free jump you can take as long as there's a Q at the top of the stack. And we have a Q at the top of the stack, so we're good. So we're going to take the free jump to 1. So we're going to say we have 1. Our string is still lambda, and since that free jump told us we did a no-op, my stack is still QX. And again, now I look and I say, oh, look, I have the string lambda. I've used up all the letters in my string. And I'm at state 1, which is an accept state, so hooray, that's in my language. So B by itself is in my language, which makes sense, right? Because my language includes A star B, which means we could have 0 A's and just a B. So we wanted this to work, so that's good. So we might want to just write B is in the language, and maybe I'll write the language another way, right? So it's A to the N B such that N is in the natural numbers, and it is a set that's unioned with the set that just contains the string BC. Okay, so all good. Let's do one more example with this. Okay, so let's just try and make sure that the string BC is in the language because we want that to be in the language, right? So we started state 0, we have BC, and our stack starts as the empty stack, which is just the letter X. And if we look at our options here, the only one that we can take is this one because we have a B as our letter and an X at the top of the stack. So we're going to take this thing that says you have a B letter and an X at the top of the stack, and we're going to push Q. So we end up, and it's a loop, so we stay at 1. We have the letter C, and now our stack has QX on it like before. And now let's see if we look. Now we have a C with a Q at the top of the stack, and check it out. We could take either this guy, which is a C with a Q at the top of the stack, or we could in fact try this one, free jump with a Q at the top of the stack. So we have two options here. Let's try this one first, just for fun. It's not actually going to bias anything, but we can try. So what we're going to do is I'm just going to kind of branch out here and say there's two different options. I guess this is a non-deterministic PDA. So in the first case, if I take the transition to state 1, then I'm not processing that C, right? It's just a lambda jump, a free jump. So I'm going to take the transition to state 1. I still have, my string is still C, and this says that I don't do anything with my stack, so it's a no op. So that, oh sorry, yeah, this one. So it says it's a no op, so I'm just going to leave the stack alone. So that's one option of where I could end up. The other option is instead, if I say I see a C, so I'm going to take this C with a Q at the top of the stack, right? C, Q at the top of the stack, and I'm going to transition using this to 1, but this transition uses up that letter C, and do a no op. So in this case, I end up doing, let's see, I end up at state 1 also, but now I have lambda as my string, and it was a no op, so I still have a QX. So now there's two possibilities, right? Just like with an NFA, there might be two possibilities, and you have to magically, remember magic sparkle dust? I don't know, did I talk about magic sparkle dust? But you have to magically somehow figure out which one works, right? Do any of these paths work? And of course, in a more complicated example, you might have a bunch of possibilities here and a bunch of possibilities here. And as long as you can find one path through this PDA that ends up with the empty string at the end and you're at an accept state, you're okay. Now, this guy over here is at state 1, which is an accept state, but the string is not empty and there's nowhere else we can go. So this particular possibility, as it were, dies out, right? This one doesn't work anymore. On the other hand, this one is fantastic because we have the empty string and we're at a string that is an accept state. So we know, therefore, that BC is in our language. Yay. Now, I've put this weird notebook slide in here just so that you will maybe stop if you're racing through the video and see what it says. Notice that in order to, it'll just catch your attention, right? So what I want to just say is remember that the key for acceptance, if you have, you have one of these triples, right? A 3-tuple. And you have, you have the state that you're at here. So this is your state, right? And this is the string that you still have to process. And this is your stack. The only thing we care about when we want to see whether whether a string is in the language or not is, can we get to a point where the string is the empty set, right? So the string is equal to the empty set, and the state that we're at is an accept state, right? That's all we need to look at. And we don't care whether there's stuff on the stack left over or not, okay? There are some approaches to using PDAs that do care about the stack, but we accept for our kinds of PDAs that we have in the book, we just accept on final state. So you get to a final state and you've processed the whole string. So notice that we've still never had to do a pop, right? We just haven't seen any examples where we've had to do a pop before. I could have stuffed some pops into that one and they would have been okay, but they wouldn't really have helped us any. And the reason that we haven't had to do that yet is because all of our examples have been regular languages, right? The examples that I've shown you, or the example that I showed you so far, is a regular language. And so I want to show you something that's a little bit harder, well, quite a bit harder, which is I want to show you a PDA for the language A to the N, B to the N. So here's a PDA that accepts the language A to the N, B to the N, as long as N is in the natural numbers, so N greater than or equal to 0. And let's just do an example to see what's going on here. Maybe a couple of examples. Let's see. All right. And remember, we always start with X on the bottom of the stack. So let's try the string AABB. Okay, that's in the language, right? And we're going to start at state 0, and the stack is going to have an X. And then we process that first A, and we have an X on the stack. So we have two options. One option is we take this path down to state 2, right, because we have an X on the stack and a free jump. And the other option is this loop here. If you look at this, that's the only one you can do. Well, those are the only two. So let's split this off, and we'll say if we take the first thing and we go to state 2, then we still have our entire string, AABB, and an X on the stack, because it was a no-op at the bottom of state 2, right? Or at the bottom of the transition, right? This says no-op here. Okay. So that's one option, and the other option is we can take this guy, stay at state 0, and push a Y. So in that case, we will have processed, here, let me just move this down here a little bit. Actually, there you go. In that case, we will be at state 0 still. We'll have shrunk our string. Our string will have used, the first A up. And our stack will now have a Y at the front of it. Ooh, let's try again, right? So we have our stack has Y and then X, okay? And now we say, okay, now if I am at state 2 with an A and an X, oh, there's nothing I can do out of there, so this one's no good. But if I'm at state 0, right, because that one was no good because I wasn't done with my string yet. I hadn't used up my string. If we look at this other situation where state 0, we have an A to process and a Y at the top of our stack. Well, look here. We have an A to process and a Y. So we can just do that and stay at state 0 and push Y. So we're at state 0. We used up that A, and we're going to push another Y. So now we have YYX on our stack. And we're actually using the Y's to keep track of how many A's, how many lowercase a's we've seen. So now we get to the point where we have a 0 on our stack. Sorry, we're at state 0. We have YYX on our stack, and we're processing a B. So we're processing B, and we have a Y at the top of our stack. Okay? So can't take this free jump because it expects an X, right? Couldn't do that for a while. But here we go, B, Y, and it says pop. So if we see a B, which we do, and there's a Y at the top of our stack, then we can do a pop. So what we're going to have is we're going to say, all right, well, now I'm moving to state 1. I am using up that first B, and I'm going to pop the Y off my stack. Well, I'm going to pop my stack, which takes the top thing off, which means now I just have YX on my stack. Okay, let's see what's next. So I'm at state 1. I have a B and a Y, so I'm here. Oh, look, I can't take this guy because even though it's a free jump, it needs an X on the top of my stack, but this loop works, so BY pop. So basically we're matching up all the B's with all the A's that we've seen. So I have BY pop, so I'm still at state 1. I used up that B, I have lambda, and I'm going to pop, so I pop the top thing off, which happens to be this Y, so I end up with X. Now I have lambda as my string, but state 1 is not an accept state yet, so I have to keep seeing if there's anything else I can do. And look here, now that I have X at the top of my stack, I can take a free jump, not just because I have a lambda here, but because this just means free jump if you have an X on your stack. So I can go from 1 to 2 on my free jump, and I end up at 2, and it says to do a no-op. So I'm going to be at state 2 with a lambda and X on my stack. And now I check again because I have the empty string here, and I say, oh, look, at state 2 is an accept state, so my string AABB is in my language. Thank goodness for that. Now we're going to try, why don't we try and do it again, and this time let's try a string that has one A and two B's, which is not in the language. Okay, so if we have the string that has one A and two B's, and we start at state 0, and we start with X on our stack, and initially I have the symbol A with an X at the top of my stack, so I have two options. I can take this one, right, because it's a free jump as long as you have an X on your stack, or I can do this loop and push a Y, but that I think is the only stuff I can do. So let's try those two options. Again, that first one isn't going to work, but you know, what the heck, we have to try it. So I'm going to end up in that first case at 2. It was a free jump, so I didn't use up any of my symbols, and it says no op, so I have an X on my stack. In contrast, if I take that loop, then I'm still at 0. I've used up that first A, and it says push a Y, so now my stack has YX. And now, of course, I have to look at each of these and say, is there a way for me to continue, or does it get accepted and not accepted because there's still a string there, right? Even though I'm at state 2, not accepted because it has to be lambda for me to accept it. Over here, I'm in state 0. 0 isn't even a double circle, isn't even an accept state. It's not a final state, so forget that. From state 2, I can't go anywhere. There's no out arrows, so this is useless. And this one, I have a B, and I see a Y at the top of the stack, and I'm in state 0. And I can't do any of my loops, but I could take this BY pop, right? So let's do that. So this one was useless. This guy, we can go to state 1. We'll use up that first B, and it said, if you see a B and there's a Y at the top of the stack and you take this transition, then you are supposed to pop. So let's pop our stack. And now we just have an X on our stack, right? So notice we just pushed one Y this time because we're sort of using the stack to count how many A's we've seen. So at this point, we're at state 1. We have a B as our letter to still process, and we have an X at the top of the stack. We can't do this BY pop loop because there's no more Y's on the stack, right? We have an X at the top of the stack. We can do this lambda X free jump thing here. In fact, that's the only thing we can do, so we might as well try. So it's going to take us to state 2. Because it's a free jump, we don't use up any letters, and now, let's see, oh, now we're at state 2, and it said we should do a no-op, so we leave X alone. And now there's nowhere we can go, right? We're sort of stuck, and well, state 2 might be a final state, but we still have a letter in our string here, right? So that still needs to be processed. So we say, oh, look, this language ABB is, sorry, the string ABB is not in our language. So what I'm going to do is I am going to show you this PDA again, a little bit bigger. Let's see if I can move it over. All right. And I'm just going to suggest that you should take a look at this example and try and do it a couple times and make sure that it all works for you. Try some other letters and some other strings and make sure that strings that should be in there are in there, strings that should not be in there are not in there. And, you know, if you try the string lambda, which is in this language, right, then what's going to happen is you'll see why we have this 0 to 2 thing, right? Great. Hope this helps.